Okay, so we started this problem in class today, and I wanted to talk about it a little bit so that you guys could get some practice on your own tackling some problems that are similar to it. And this is where the calculus takes over from being just straightforward a way to get a formula for the derivative or formula for the slope anywhere and actually applying that to a particularly challenging situation. So the situation that's going on here is we have this curve that we don't exactly know where it is. We know it's y equals k over x. We talked about in class how the k, the constant that's unknown, will change the shape of this curve. It could make it come down and kind of turn sharply, or it could make it come down and kind of turn gently. But if it comes down just right, it's going to be tangent to this line, y equals negative 3/4 x plus 3, that of course we know where it is. It has a y-intercept of 3, it has a slope of negative 3/4, so it comes down 3/4, it goes like that. So what we're asking is what value of k would make this curve be just right, that it comes down and nicks that line at one point and then goes on its way. So what we have to think about is what's happening at that point. So I've highlighted that point in purple. And I think we could agree with two things. When two lines intersect at this point, which we could, I don't know, we could call it, I guess, xy for now. When two curves intersect, or when a line and a curve intersect, what we can say about them is that the two equations normally are equal, or their y values are equal at that 2 points. So if you want to think about the orange curve being this guy here, the line. This equation is given for that line, and this equation y equals k over x is going to be this curve thing. We could say that those two y values are equal to each other. Now I don't have an orange pen on here, but I have a yellow one. So we could say that y equals, so we'll make this line yellow. That's what I'm saying. So that equation, which is negative 3/4 of x plus 3, would have to be equal to our blue equation, which is the curve. So that has to be equal to k over x. Now you look at that equation and you say, well, I have two things missing here. We've got x that's missing and k that's missing. And so you have one equation with two unknowns. It's not solvable. But that's not the only piece of information that we have going on there. Because you think, okay, well, that's basically an algebra idea. When two curves intersect, their y values are equal. So that's basically an algebra approach to this. What we now have at our disposal is calculus, which says, hey, at that one point, at that purple point, that we don't know where it exists, the y values are certainly equal to each other, but not only that, their slopes are equal to each other. So the slope of the blue curve is equal to the slope of that yellowish line. So that's a second, kind of separate topic. So we'll make a little note of that over here, maybe saying this information is given by the y values being equal. So I'm going to say y values are equal. And then we can have a separate kind of relationship over here saying that the slopes must be equal. So that's going to be kind of cool because now we can put to use our calculus. So the slope of this yellow line, I could find an Algebra 1 student to tell us what that must be. The slope of the yellow line, obviously, is negative 3/4. Now, the slope of the blue curve requires a little bit of calculus. So if we want to think of this k over x as being k times x to the negative first, where k, again, is just some constant that we don't know, if we were thinking about the slope of that blue curve, we can think about the calculus definition of slope, which is going to, or the calculus way we're going to find the slope, which is bringing the power down in front, so that negative 1 is going to come down in front and get multiplied by the k, and then we're going to drop that power by 1. So we're going to say negative 1 times k, and then we're going to have x raised to the negative 2. So there's a second equation that we have. Now, it's not a pretty equation. It's a little awkward there. So I'm going to clean it up and say that negative k x to the negative 2 would be like the opposite of k over x squared. So we've got to be really solid with our properties of exponents. What does it mean to be a negative exponent? And of course, that's equal to negative 3 over 4. So there's a relationship, and if we want to go a little bit further, we may as well multiply both sides by negative 1, or divide both sides by negative 1, and get that 3/4. I'm just going to go all black now since I think we've achieved our purpose of having the color. 3/4 equals k over x squared, and that's going to be pretty valuable. So let's maybe take that same approach back over to this other work here where we had the y values being equal to each other. The y value of the yellow line is equal to the y value of the blue curve. So we have the yellow line's y value, which is negative 3/4 of x plus 3, is equal to the y value of the blue curve, which I will write as k over x. So let's now take a look at that and say, what can we do here to kind of get things cooking? Well, we could take, we need to use our algebra skills now to solve this system of equations, because we've got an equation here, an equation here, and we need to do something with that. So why don't we, I think it would be pretty easy to isolate k here in this equation. So if I multiply both sides by x squared, think about just coming along here and multiplying by x squared here and by x squared there. That's going to kill that, and I get k is equal to 3x squared over 4. So I can use that information, take that known truth, that's got to be true, and take that k, that's 3x squared over 4, and plug it in for this k here. And then I'll have an equation that will only have x's in it. So that's what I'm going to do. I'm going to take that 3/4 of x squared and drop it in right there. And that's going to become 3/4 of x squared, ugly 2, over x. And that's equal to negative 3/4 of x plus 3 from above. Now, this is kind of convenient on the right side here. Those two guys are going to reduce. That's going to be x squared over x, which reduces to just an x in the numerator. And that gives us 3/4 of x. And on this side, we have negative 3/4 of x plus 3. And now we just have some basic algebra to contend with. We're going to get our x's over on the right side. So I'm going to add 3/4 of x and add 3/4 of x. And now we have 3 is equal to 6/4, which of course reduces to 3/2 of x. And that's going to say, if basically just multiply both sides by 2/3. And I'm going to get x equals 2. And I know that algebra got a little ugly down there at the bottom because I ran out of room. But you got it. Now, there you box the answer, you put your pencil down, you walk away, and you wonder why you got the question marked wrong. And the reason you got the question marked wrong is because we were not asked about find the value of x that makes this situation true. We were asked about finding the value of k that makes this line be tangent to this curve. So what does k have to be? Well, we're basically there, because all we have to do now is realize that x equals 2, and k is 3x squared over 4. So we can simply back substitute, take this information that x is 2 and put it back in there for that x, and say that k would be 3 times our x value, which is 2 squared over 4. And I think you realize 2 squared is going to be 4, which is going to cancel out that, and we get k equals 3. So there's our solution. So if we were to take the curve y equals 3 over x, and this might be a good exercise for you. Go to your calculator or good grapher and graph 3 over x, and graph y equals negative 3/4 of x plus 3, and you'd see that the picture would look a whole lot like the one I have drawn here. So that's a good example of using two equations with two unknowns, setting a point of tangency where the y values are equal to each other and the slopes are equal to each other. That's going to be a concept we're going to use a decent amount this year. All right, you're going to get some practice problems on this, and you would certainly be tested on it.